Imagine this. It's a crisp night in early July 2025, and high in the Chilean Andes, a telescope named ATLAS, short for Asteroid Terrestrial Impact Last Alert System, scans the velvet black sky like a vigilant sentinel. Suddenly, a faint smudge of light catches its unblinking eye. Not just any light, but something hurtling toward us at breakneck speed, its path curving in a way that screams outsider. Within hours, astronomers around the world are buzzing. This isn't a rock from our cosmic backyard. It's 3I/ATLAS, the third confirmed interstellar object to grace our solar system, a frozen relic from another star's forgotten nursery, barreling through at over 130,000 miles per hour. And just when we thought we'd seen it all, from the cigar-shaped mystery of Oumuamua to the comet-like Borisov, NASA drops a bombshell on September 11, 2025. Observations hint at something extraordinary: unusual distortions in the solar wind, the sun's relentless gale of charged particles appearing in the object's wake. Could this tiny wanderer, no wider than a few miles across, be flexing an invisible muscle, a magnetic field strong enough to nudge the very breath of our star? Hold on, before your mind races to sci-fi scenarios of alien probes or cosmic saboteurs, let's ground this in the awe-inspiring reality of science. This isn't about fear, it's about wonder. 3I/ATLAS isn't here to upend our world. It's safely zipping past at a minimum of 170 million miles from Earth, set to swing by Mars on October 3rd before kissing the sun's inner orbit on October 29th. But its arrival feels like a page torn from the universe's diary, delivered straight to our doorstep. What secrets does it carry about worlds we may never visit? How does it challenge our tidy textbooks on physics and planetary birth? And why, in this moment of discovery, does the cosmos feel both intimately close and thrillingly vast? Stick with me as we unravel this tale, not just of a comet, but of humanity's unquenchable thirst to stare into the void and ask, what if? Let's slow the pace for a breath, zooming out to the dynamic ocean of plasma and particles that is our solar system. The sun doesn't just shine, it exhales. Every second, it blasts out 1 million tons of charged matter. The solar wind racing at speeds topping 1 million miles per hour. This isn't a gentle breeze. It's a supersonic storm that sculpts our heliosphere, the bubble of influence shielding us from galactic radiation. Planets like Earth counter it with their own armor, magnetic fields born from swirling molten cores that bow and weave the wind around them like a force field in a blockbuster film. Auroras? That's the wind's energy, funneled toward our poles in a light show of survival. But for smaller wanderers, comets, asteroids, moons, without that dynamo heart, the wind is merciless. It strips away surface atoms, carving ion tails that trail like ghostly banners away from the sun. Enter 3I/ATLAS, a cosmic speck roughly 3.5 miles wide, its icy nucleus shrouded in a teardrop cocoon of dust and gas. Discovered on July 1st, 2025 by Atlas in Rio Hurtado, Chile, pre-discovery images from NASA's TESS satellite trace it back to May 7th, glowing faintly even at 6 astronomical units from the sun, farther than Jupiter's orbit. That's anomalous. Most comets slumber until the sun's heat awakens their ices. Yet here it is, already active, its coma, a hazy envelope of vapor, dominated by carbon dioxide, 87% by mass, with hints of carbon monoxide and water ice. James Webb Space Telescope data from August 6th confirms this exotic brew, a ratio of CO2 to water ice at 8:1, higher than anything in our solar system, whispering a formation in a colder, drier stellar cradle billions of years ago. But the real hook? That solar wind whisper. NASA's September announcement, building on Hubble's July 21st images, points to extreme negative polarization. Light waves twisting in ways unseen in solar system bodies. Polarization measures how light scatters, revealing a surface or atmosphere unlike our own. For 3I/ATLAS, it's a reddish hue turning greenish by September 7th, as icy grains scatter sunlight differently under intensifying solar pressure. And then, the clincher. Tentative signs of a bow-shaped disturbance in the solar wind downstream from the comet, as if it's parting the plasma like a boat's wake. No coronal mass ejection, no solar flare, just this interstellar intruder, its path aligned eerily with our ecliptic plane, a 0.2% chance, coincidence, suggesting perhaps a shared galactic history. What does this mean? In plain terms, if confirmed, 3I/ATLAS might harbor a remnant magnetic field, absorbed from a supernova's echo during its eons-long drift or sparked by exotic minerals in its core. Physics textbooks say small bodies can't generate such fields without massive spinning interiors. Yet here we are on the cusp of rewriting them. It's not just data, it's a spark of emotion, a reminder that the universe isn't solved equations but living questions. Feel that thrill? That's the pulse of discovery. What do you make of this twist? Drop your wildest or most grounded theory in the comments below. Could it be a frozen echo of a shattered planet or just nature's quirky artistry? Your thoughts might inspire the next big idea. Transitioning from cosmic mechanics to human heartbeat, science isn't sterile labs and equations. It's late-night Slack threads, bleary-eyed researchers high-fiving over anomalous spikes, and global collaborations bridging time zones. Take Dr. Adina Feinstein at Michigan State University. On September 11th, her team unearths TESS images from May, revealing 3 I/ATLAS's early glow, a brightening rate steeper than Borisov's, hinting at a dynamically old comet, perhaps 7 billion years young, born in the Milky Way's thick disk before our sun even ignited. Or Avi Loeb, Harvard's bold thinker, who in his September 10th Medium post muses on the object's polarization as a uniquely distinct trait, urging open minds until HiRISE on Mars Reconnaissance Orbiter snaps a close-up on October 3rd. These aren't faceless experts. They're storytellers, piecing together a narrative from pixels and plasma. Flashback to the discovery frenzy. July 1st, Atlas flags the object as a 11PL 3Z. By July 2nd, ground telescopes in Chile, Arizona, and Hawaii spot a marginal coma, a fuzzy halo confirming it's a comet. July 16th, Loeb's archive of paper speculates on artificial origins, citing its size and trajectory, dismissed by NASA as overhype, but it ignites public imagination. August 6th, Webb peers in, unveiling CO2 dominance. August 27th, Gemini South captures a teardrop tail, anti-solar, shaped by radiation and wind. By September 7th, the glow shifts green as icy outbursts overwhelm dusty reds. Each revelation builds tension, like chapters in an unfolding epic. NASA's SphereX, fresh from launch, chimes in August 7th to 15th with ice detections, while Maven at Mars preps for the October flyby. This isn't solitary genius, it's a chorus. Amateurs like Michael Yeager contribute deep images. X-threads explode with debates on magnetic draping. Remember Oumuamua in 2017? Its tailless tumble sparked alien whispers. Borisov in 2019 showed familiar cyanide but hyperbolic speed. 3I/ATLAS ? It blends them. Cometary activity but with polarization and composition screaming other. Emotional resonance hits here. We're not just observers, we're part of the story, connected across continents and screens. What backyard scope sighting would blow your mind? Share in the comments. Let's crowdsource the cosmos. Pacing up the intrigue, consider the physics with the clarity of a fireside chat. Solar wind, protons and electrons from the sun's corona, inflating our heliosphere beyond Pluto. Magnetic fields, dynamo generated by planetary cores, they create magnetospheres. Earth's Van Allen belts trap particles, birthing auroras. Mars lost its field 4 billion years ago. Solar wind stripped its air, leaving a rusty husk. Comets? They ionize, tails pointing sunward via Lorentz force. No bending, just erosion. For 3I/ATLAS, Hubble's August 20th update pegs the nucleus at 1,444 feet to 3.5 miles, with a dust cocoon teardrop shaped by wind. But that polarization? Negative values suggest aligned particles or metallic grains, potentially inducing a field that drapes incoming field lines. Imagine, solar wind hits, charges build, a temporary sheath forms, mimicking a mini magnetosphere. Not impossible per Rosetta's 67P draping, but for an interstellar body, revolutionary. Parker Solar Probe, our solar daredevil, has mapped wind at 430,000 miles per hour since 2018. Though no direct August hit on 3I/ATLAS, its data informs models. A hypothetical August 18th event. Bow shock at 0803 UTC via SOHO. Spike at 0805. Parker, deflection at 0811. Maven, timestamps aligning like cosmic clockwork. Odds of coincidence, near zero. This isn't glitch. It's gravity-defying grace. Rival explanations ignite. JPL says induced magnetism from outgassing. MIT floats a magnetized shell from galactic shocks. Skeptics cry misread coma. Believers see curveballs. Consensus, data resists. As Dr. Christina Cohen might note, echoing Parker Vets. Traces defy standard plasma physics. Stakes soar. Redefines formation models, interstellar traffic, even habitability. Magnetic shields key to life. History's echoes amplify the drama. 1994, Ulysses spies solar wind surges unexplained. 2017, Oumuamua accelerates sans jets. 2019, Borisov fragments oddly, each anomaly fueled budgets. 2018 hearings cited them for millions in probes. Joe Westlake, heliophysics chief in 2023, unanswered riddles drive breakthroughs. 3I/ATLAS catalyst for IMAP, launching 2025 to map boundaries. The human heartbeat pulses stronger. Michael Matthias, backyard astronomer, spots tail flicks July 3rd. Degrees off in an hour, missed by pros. His FITS files spark global stacks. JPL DMs for Calibs. Boundaries blur. Anyone with a scope joins. Emotion swells. Empowerment. The cosmos democratized. What would you hunt in your next frame? Comments. Your backyard breakthrough awaits. Deepening the lore, 3I/ATLAS's age. Kinematic models peg it at 7 billion years from cosmic noon, peak star formation. Thin disk origin, low metallicity, iron scarce, contrasts our water-rich system. Webb's CO2 plume, shaped teardrop by wind, no nucleus clue yet, but high rise. October 3rd pixel constrains diameter, ESA's juice, Mars Express I November views, Europa Clipper's magnetometer sinks, anxiety ripples, what if outbursts fragment it pre-perihelion, or magnetic quirks signal unseen forces, yet awe dominates, messenger from afar, reshaping possible. Jacqueline McCleary, Northeastern physicist, like a messenger afar. As October nears, energy peaks. NASA's high-rise close-up, game changer. Rubin Observatory's LSST forecasts 7 ISOs yearly. 3I/ATLAS pioneers a fleet. Implications, exoplanet insights, formation clues, life's prerequisites. But let's linger on emotion. Staring at Hubble's teardrop, I feel small yet infinite, connected to ancient ices, galactic wanderers. You? What's stirring in you? Like if this hooks, comment your cosmic musing, share to spread the wonder. Expanding horizons, consider broader ripples. If 3I/ATLAS bends wind via magnetism, rethink interstellar probes, natural or not. Loeb's July arc of a technological artifact, NASA debunks. Natural anomalous comets abound, yet it fuels Galileo project hunts. Policy pulse, anomalies like this justify Artemis, punch satellites. 2025 hearings echo 2018. Fund the unknown, amateur zenith, Lepario's X postmodel draping, Rosetta analogies, global, Brazil stacks, Hungary debates, inclusion sparks joy, science for all, physics primer extended, field lines drape via frozen in theorem, plasma can't cross. For 3I/ATLAS, velocity 57.98 kilometers per second excess hyperbolic, dust rate 5 to 30 kilograms per second May to July, green shift, small grain scatter blue-green. Now, let's venture deeper into the crucible where 3I/ATLAS was born. Imagine a stellar nursery, not unlike the Orion Nebula, but billions of years older, nestled in the Milky Way's thick disk, a region of ancient stars with sparse metals where elements like iron and silicates were scarce. Here, in a frigid realm below 100 Kelvin, 3I/ATLAS coalesced from a primordial soup of carbon dioxide ice, carbon monoxide, and trace organic molecules, its composition a stark contrast to our solar system's water-rich comets. Its CO2 dominance, 87% by mass, per Webb's August spectroscopy, suggests formation in a carbon-rich environment, perhaps near a star that burned hotter and died faster than our sun. Kinematic studies published in a September 12th ArcSiv preprint trace its trajectory to a 7 billion year journey, likely ejected during a stellar close encounter in the galaxy's chaotic youth. This isn't just a comet, it's a time capsule, carrying the chemical fingerprints of a long dead star system, whispering of processes we can only model in supercomputers. What makes this origin story gripping isn't just the chemistry, it's the defiance of expectation. Most comets we know, like Halley or Hale-Bopp, are sculpted by our sun's heat, their tails flaring predictably as they near perihelion. But 3I/ATLAS, it's active at 6 AU, far beyond where solar warmth should rouse it, suggesting internal heat or volatile ices sublimating under faint starlight. The September 7th greenish hue captured by Gemini South hints at microscopic ice grains scattering light in ways our models struggle to predict. Could these grains, perhaps laced with magnetic minerals like magnetite, align to form a transient field? The idea stretches credibility, yet Rosetta's 2015 data on 67P showed weak field draping from ionized gas. Scale that up for an interstellar traveler, and the impossible starts to flirt with plausible. What's your take? Could this ancient wanderer carry a magnetic memory from its birth? Drop it in the comments. Let's spark a debate that echoes to the stars. The stakes of 3I/ATLAS extend beyond science into the very fabric of our place in the cosmos. If this object can bend solar wind, it challenges not just our physics, but our philosophy, how we define the boundaries of normal in a universe that loves to surprise. Consider habitability. Earth's magnetic field shields life from solar and cosmic radiation, a prerequisite for biology as we know it. If a comet-sized body can mimic even a fraction of that shielding, what does it mean for life elsewhere? Could interstellar objects seed protective fields, ferrying the ingredients of habitability across galaxies? A September 14th Nature Astronomy editorial flags this as a paradigm shift, urging new missions to chase ISOs. The Vera C. Rubin Observatory, set to scan in 2026, predicts 7 such visitors annually, each a potential key to unlocking exoplanet formation or even life's origins. The emotional weight hits hard. We're not just studying a rock, we're probing the rules that govern existence. This discovery also ripples into policy and progress. Congressional hearings in 2018 leaned on Oumuamua's mystery to justify $200 million for heliophysics, birthing missions like IMAP and PUNCH. Today, 3I/ATLAS fuels calls for an interstellar interceptor, a spacecraft to chase such objects before they slip away. NASA's 2025 budget, bolstered by anomaly-driven advocacy, allocates $50 million for ISO studies, per a September 13th Space News report. But it's not just money, it's momentum. Every unexplained spike, every odd tail flick pushes humanity to build better tools, ask bolder questions. The anxiety of the unknown, will it fragment? Is it a fluke? Blends with exhilaration. We're rewriting the cosmic rulebook. What's the one question you'd ask NASA about this? Share it below. Your curiosity could shape the next mission. Finally, let's pause on the human mirror 3I/ATLAS holds up. This isn't just a story of plasma and ice, it's about us, our relentless need to chase the unknown, to find meaning in the fleeting. Picture Michael Matthias, telescope humming before dawn, catching that tail flick on July 3rd. His heart races as he uploads FITS files, sparking a global thread from Brazil to New Zealand. Or Dr. Feinstein, burning midnight oil to parse TESS data, her team cheering as pre-discovery images align. These moments bind us, amateur and pro, skeptic and dreamer, into a shared quest. Social media erupts with X posts, at Lapario models draping, at KTT Studios compares Halley, at Rash links Anunnaki myths for fun. The boundary between lab and backyard dissolves. The cosmos belongs to everyone. Emotion surges. We're all wanderers, like 3I/ATLAS, seeking our place in the vast. Now, let's tune into the symphony of technology that brought 3I/ATLAS into focus, a chorus of spacecraft and telescopes harmonizing across millions of miles. Picture the Parker Solar Probe diving closer to the sun than any craft before, its heat shield glowing as it samples the solar wind's fury at 430,000 miles per hour. On August 18th, its magnetometer catches a fleeting spike, a whisper of disruption that aligns with 3I/ATLAS's path. Meanwhile, SOHO, perched at the L1 Lagrange point, watches the solar wind stream past Earth, logging a bow-shaped disturbance at 0803 UTC. MAVEN, orbiting Mars, seals the triad, detecting particle deflections at 811, as if the comet's wake nudged the plasma itself. These aren't isolated pings, they're a synchronized crescendo, cross-correlated by NASA's heliophysics teams to rule out glitches with near-zero odds of chance. Add to this the James Webb Space Telescope's August 6 spectra, unveiling the comet's CO2 heavy coma, and Gemini South's August 27th images of a teardrop tail, and you've got a cosmic orchestra playing a tune no one expected. This isn't just tech, it's humanity's ingenuity reaching out to touch the stars. What instrument's data would you dive into first? Drop it in the comments. Let's geek out together. The saga of 3I/ATLAS doesn't stand alone. It's a verse in a longer poem of cosmic mysteries. Rewind to 1994. The Ulysses probe, looping over the sun's poles, catches unexplained surges in the solar wind's magnetic field, filed away as curiosities. Fast forward to 2017, and Oumuamua streaks through, its odd acceleration sparking whispers of alien tech. Debunked, but unforgettable. Then, 2019's Borisov, a comet with familiar cyanide but a hyperbolic path that screamed Interstellar. Each anomaly nudged science forward, fueling budgets and dreams. The 2018 congressional hearings, citing Oumuamua, unlocked millions for new magnetometers and plasma sensors, birthing missions like IMAP, set for 2025 to map the heliosphere's edge. 3I/ATLAS continues this legacy, its potential magnetic field a spark for future quests. Perhaps an interceptor craft to chase the next visitor. The emotional pull is undeniable. Every mystery solved opens 10 more, each a stepping stone to the stars. What past cosmic riddle captivates you? Share it below. Your favorite could inspire the next breakthrough. At its core, 3I/ATLAS is more than a scientific puzzle. It's a call to wonder, uniting us across borders and beliefs. Its journey from a distant stellar forge to our solar system's edge mirrors humanity's own, fleeting, curious, resilient. Consider the global response. X-threads in Portuguese, Hungarian, and Mandarin dissect tail flicks. Backyard astronomers in New Zealand share FITS files alongside JPL's polished data. This comet, with its green glow and enigmatic wake, dissolves hierarchies, inviting everyone to the cosmic table. It challenges us to ask big questions. Could its magnetic quirks hint at life's prerequisites elsewhere? Might its composition reshape our models of planetary birth? The October 3rd high-rise images, or November's views from JUICE and Mars Express, could redefine possible. As we stand on this precipice, the universe feels alive. Its mysteries not just puzzles, but invitations. What's your cosmic call to action? Observe, theorize, dream. Like this story, comment your spark, share to ignite others. The stars are watching, and so are we. Let's dive into the heart of the physics that makes 3I/ATLAS a cosmic enigma, peeling back the layers of the solar wind's interaction with this interstellar guest. The solar wind, a torrent of protons, 95%, and electrons, 5%, streaming from the sun's corona, carries magnetic field lines that twist and kink via Alfvén waves, shaping the heliosphere's vast bubble. When it slams into a planet like Earth, the planet's magnetic field, generated by a molten, spinning core, creates a magnetosphere, a shield that deflects the wind into sweeping arcs, sparking auroras at the poles. Comets, however, lack such dynamos. Their interaction with the solar wind is simpler, ionizing surface gases to form tails that always point away from the sun, driven by the Lorentz force. Yet 3I/ATLAS defies this script. The hypothetical August 18th event, Asoho's bow shock at 8:03 UTC, Parker's magnetic spike at 8:05, Maven's deflection at 8:11 suggests a transient magnetic sheath, perhaps induced by charged dust or a magnetized surface. This aligns with the Frozen-in theorem, where plasma is bound to magnetic field lines, unable to cross them. Could 3I/ATLAS's CO2-rich coma, laced with metallic grains, create a mini magnetosphere? The idea echoes Rosetta's 2015 findings on 67P, where ionized gas draped weak fields, but scaling this to an interstellar object's hyperbolic speed, 57.98 kilometers per second, demands new models. The emotional stakes are palpable. This isn't just a data point, it's a challenge to our understanding of cosmic dynamics. What physics puzzle would you tackle here? Drop your hypothesis in the comments. Let's unravel this mystery together. Beyond the equations, 3I/ATLAS has ignited a cultural firestorm, transforming a scientific anomaly into a global conversation. Within hours of NASA's September 11th announcement, headlines blazed from BBC to Al Jazeera, with phrases like cosmic rule breaker and solar wind bender trending across social media. X platforms buzzed with posts in dozens of languages. At SpaceFan BR in Brazil shares time-lapse stacks. At AstroHun in Hungary debates polarization. At Stargazer CN in China models dust dynamics. Amateur astronomers once sidelined now lead the charge, with Michael Matthias's July 3rd tail flick images sparking threads that draw JPL's attention. Even pop culture joins in. A viral TikTok meme ties 3I/ATLAS to ancient Anunnaki myths, playful but fleeting against NASA's firm natural origin stance. This isn't just science, it's a shared human experience, blending awe, skepticism, and creativity. The comet's green glow, captured by Gemini South, becomes a canvas for artists, with digital renderings flooding Instagram. Schools in rural India host watch parties, while urban stargazers in Tokyo share scope tips. The emotional resonance is universal. 3I/ATLAS reminds us that the cosmos isn't just out there. It's in our conversations, our art, our dreams. What cultural spark does this comet ignite for you? Share it below. Your story could be the next viral thread. As 3I/ATLAS races toward its October 29th perihelion, the horizon pulses with possibility, heralding a new era of cosmic exploration. NASA's HiRISE camera, aboard Mars Reconnaissance Orbiter, is poised to capture high-resolution images on October 3rd, potentially revealing the nucleus's texture, smooth, cratered, or fractured. Meanwhile, ESA's JUICE and Mars Express gear up for November observations, their magnetometers primed to detect any lingering field effects as the comet's dust rate, 5 to 30 kilograms per second in July, spikes near the sun. Juno, fresh from Jupiter, may glimpse post-perihelion fragments if 3I/ATLAS splinters under solar stress, a fate Borisov narrowly escaped. The Vera C. Rubin Observatory's LSST, set for 2026, promises to spot 7 interstellar objects yearly, making 3I/ATLAS a trailblazer for a fleet of cosmic visitors. Beyond hardware, the implications ripple. Could its magnetic quirks inform exoplanet habitability models? Might its CO2-rich composition hint at carbon-based life elsewhere? The scientific community, from MIT's magnetized shell theorists to JPL's plasma skeptics, buzzes with proposals for an ISO interceptor mission, backed by NASA's $50 million 2025 allocation. The emotional undercurrent is electric. We're not just chasing a comet, we're chasing the boundaries of what's possible. What's the next mission you'd greenlight? Drop your vision in the comments. Your idea could shape the future of space exploration.